Here the question is given in the descriptions of GATE 2019. We need to find out the maximum deflection at the free end of this cantilever beam, and we have given the Young's modulus and the moment of inertia. And this is the cantilever beam, uniformly loaded beam. It is uniformly increasing, and the maximum load is Q, and this is given that Q is unit load for the unit length. So it is given that Q is for the unit length, so QL for the total length, so it will be Q. So let's take arbitrary distance for the small section. What will be the deflection, and then we will integrate for the whole till length. We will get the total deflection. This is the free end. We need to find the deflection at this end. Let's take qx for the distance x, and this qx will be q for the unit length. It will be for q upon l for the length x, so ql into x. So this is the cantilever beam, and the maximum load is q. We know that this is the equation for, and we will integrate this. EI d square y by dx square is equals to m. This is the bending moment m, and now moment is equals to load into length. Here load will be minus p, this whole bracket will be load, and into L. Why it is minus? Because the load will be downward, so we are taking downward as minus, upward positive. So this formula, this is the basic formula. When we'll integrate, it will become like this, and on another integration it will come like this. So why moment is this? Because 1 by this moment is load into area, load into length. So load is this load amount. Due to this load, what will be total load? So the total load will be the area of this small section. What will be the area of this? It is a triangle. 1 by 2 into base into height. Base will be x and height will be qx. 1 by 2 into base into height, qx into L. Qx is equals to this, and this is x by 3. Why it's x by 3? Because this is triangle, and this load for this triangle, the centroid will be somewhere here, and the centroid distance from the centroid to the left, this centroid will be here, and this length will be x, total length upon third, 1 by third of the length, and this will be 2 by third of the length. So the moment will be acting from on this point, so moment into this length. So moment to this length will be x upon 3, and this will be 2x upon 3. So this is why we have written x by 3. So this load into L, this is minus, and we'll multiply this, we will get this. Now we know that here won't be any deflection, and here won't be any slope. So when we integrate this, we will get this. But at x is equals to L, the slope will be 0. dy by dx is equals to 0. This is the slope, and this and here deflection is also 0 at x is equals to L. So when we will put this dy by dx as 0, we will get C1 as QL cube upon 24, and we also know that y on deflection at B is equals to 0. So at this also deflection will be 0. So when we will integrate this, EI, this will come, and we have got the value of C1. We need to find out C2. When we put lambda B or y is equals to 0, so it will be 0 here, and we will get by putting C1 here, and C2 we will get as this. It is minus because it's downward. Now we need to find out the deflection at this free end, which is at x is equal to 0. So when this formula is written like this, at x is equal to 0, so here putting all these x as 0, and this C1 value from here over here, and C2 value from here, when we put 0, and this will become 0, this will become 0, and when we'll multiply this, we will get ql cube on 30 ai. This is negative sign because it's downward. I hope it's clear. Thank you for watching.